All right, greetings everyone. The purpose of this video is to go over some basics of the unit circle and really basics of how the unit circle is constructed. Now, as you go through this course, it'll be really important that you have the unit circle kind of implanted or tattooed on your brain, so more or less memorized. However, rather than having to memorize the whole thing, you'll kind of see in this video how it's built from just angle measures in the first quadrant, and you can use that to help you build the whole unit circle. Okay, so let's start with some basics that we talked about in section 5.3. So we defined our sine function of a particular angle theta as the ratio of y over r, where y is the y coordinate of the point corresponding to that where the terminal side of the angle intersects the circle, and then r is the radius of the circle. And the cosine function we defined as the cosine of the angle is the ratio of x over r, where x is the x coordinate of where the terminal side meets the circle, and r again is the radius. So let's get a visual for this, just to remind ourselves. So if this is our coordinate axis, if we have a circle centered at the origin, okay, so the center of this circle has to be the point 0, 0. And then we have an angle measured in standard position, means its initial side is there along the horizontal axis on the positive side. We rotate around whatever that angle theta is, and then we have the terminal side here. And again, where that terminal side intersects the circle, that's going to be our point x comma y. Okay. And again, the sine of that angle will be given by the ratio y over r. The cosine will be given as x over r. Now, we also talked about what happens if the value of r, the radius, is equal to 1. Well, first of all, if the radius is equal to 1 and the circle is centered at the point 0, 0, then we know we're talking about the unit circle here. And also, if we look at the ratios for sine and cosine, we've seen that the sine of the angle is now given by y over 1, since the length of the radius is 1, which just equals y. And the cosine of the angle is given by the ratio x over 1, which is just x. So what we see in the unit circle then is that this point xy will actually represent the cosine of the angle, comma, the sine of the angle. And again, that's only on the unit circle. On other circles, that's not true, but it's an important and helpful fact about the unit circle. Okay. All right, another important thing we need to keep in mind to help us build the unit circle is this idea of reference angles. Oops, sorry about that. So recall that the reference angle of a particular angle is that angle between 0 and 90 that is measured back to the horizontal axis from the angle. So here you can see in these instances where all the reference angles would be. If I give you an example, say considering the one that I was just looking at, that I drew on that last example. So here's our circle, and then we've got our initial side here. We rotate around to our terminal side here. Okay, that whole about 2/3 of a rotation there, not 2/3, a little over 1/2 of a rotation there. That's the whole angle theta, but then the reference angle is going to be this smaller angle right here, measured back to the horizontal axis. And again, I want to emphasize that a reference angle is always measured back to the horizontal axis. Now, reference angles are important because angles share the same cosine and sine values as their reference angles, except for the signs might be different on them, so the positives or negatives, okay? And this ends up being helpful to for us to build the unit circle, because there's just some basic reference angles for which we can memorize the sines and cosines, and we can use that to build the rest of the unit circle. And those basic angles we can use are really these three here in the middle. So pi over 6 are 30 degrees, pi over 4 are 45 degrees, and pi over 3 are 60 degrees. Okay. And you see there in the tables the cosines and the sines for each of those. So for pi over 6 and 30 degrees, the cosine is root 3 over 2 and 1/2, and the sine is 1/2. For 45 degrees or pi over 4, we see that the cosine is root 2 over 2, and the sine is also root 2 over 2. And then for pi over 3 or 60 degrees, and the sine is root 3 over 2. We also have in this table here the cosine and sine for an angle measure of 0 degrees or 0 radians. Those are the same. Or pi over 2 radians or 90 degrees there. Now, you can memorize those from this table, but also as we start to construct the unit circle, I'll show you how those actually come from, or you can find them pretty quickly by just looking at the coordinates on the circles. Okay, so this takes us now to the unit circle, and we're going to begin to fill in some angles here. Now I'm going to start by filling in the ones that we just saw on that last slide. And as a reminder, when we measure angles, right, we start here from the positive part of the horizontal axis. And that first angle will come across there. That would be 0 degrees, which is also, right, 0 radians. And then if you recall from what we just saw in that table, the cosine of that angle is 1 and the sine was 0. Okay, which again might seem a little arbitrary, but let's think about again how the unit circle works and what those coordinates would be right there at that point. So I'm drawing a little diagram off to the side here to try to help with this. So trying to find the sine and cosine, I'm actually trying to find the points on the unit circle right there. But recall that the radius of the unit circle is 1. So we know the distance from the center out to that point is going to be a length of the radius. That's going to be 1, which means on the horizontal axis there, we've really gone over 1 unit, which tells us then that the input value there, the x value, will be 1. And then notice we haven't gone up or down at all, so we know that the y value or output value there is 0. So that's where this 1, 0 comes from for 0 degrees or 0 radians. Okay. And then we can go around filling in the other values from that table in order. So we'd have, the next one was 30 degrees, which was pi over 6 radians. Recall again the cosine there was root 3 over 2, and the sine, or the sine was 1/2. And then the next one we have is 45 degrees, which is pi over 4. And we saw again that the cosine there was root 2 over 2. Sine was root 2 over 2 as well. And then for 60 degrees, that was the next one. The radian measure there is pi over 3. And then the cosine and the sine are 1/2 and root 3 over 2. So notice now we've got that whole, almost that whole first quadrant filled in. We'll still got to fill in this top box here. But just from that table we saw, we can fill in all of those values. And we can actually also fill in that value there on the top. So recall that this is now, we've basically rotated a quarter turn around the circle, which means we're looking at 90 degrees here, which in radians is pi over 2. And there we saw that the cosine was 0 and the sine was 1. And let's again think about why that is if we look at my little diagram here off to the right. So we're looking for this point right here. And notice to get to that point from the origin, well, first of all, we don't go left or right at all. So we know the input value, the x value there is going to be 0. And then we again use the fact that the radius has a length of 1 to know that we've gone up 1 unit from the center there, which means our output value or y value there is 1. So this 0.01 is how we know what this one is here. All right. And what we can do now is use the information in that first quadrant to help us fill in information in all the other quadrants. And actually, before I start filling in the quadrants, I'm also going to fill in the angles that are right on the axes. So if I go another quarter turn around the circle, then I end up here at this angle, which now I've gone halfway around the circle, so that would be 180 degrees, which if you convert that to radians is pi radians. And the cosine and sine there will be -1, 0. And again, if you look at the unit circle over here, or this drawing, you can hopefully see why that is. And then if we do another quarter turn around the circle, we're now going to be down here at the bottom. We've gone 3/4 of the way around the circle, so that'll be 270 degrees, which in radians is 3 pi over 2. And then the cosine and sine there in this case will be 0, -1, which again, if we think about the coordinates here, that helps us come up with that. And then we can actually go another quarter turn around the circle to end up back where we started. And notice if we do that, we've now gone a full rotation around a circle, which is 360 degrees, which if you convert that to radians is 2 pi. And there, because we're back at the same point we were for 0 degrees or 0 radians, the cosine and sine there will be the same as what they are for 0 degrees or 0 radians. Okay, so now here's where it gets fun. We're going to fill in the other angles. And again, to do this, we're going to use the idea of reference angles, which is going to relate to the information we're given in the first quadrant. So I'm going to focus right now on this angle right here. Okay. And I need to figure out what that angle is in both degrees and radians, and then what its cosine and sine value are. Well, first of all, notice that the reference angle for that angle is going to be right here, kind of that smaller angle, which hopefully you agree with me that corresponds to the 30-degree angle over here, right? It looks like they're the same size. So it tells us that the reference angle here is 30 degrees. Okay. We also know that this angle we're looking for is between 180 degrees and 90 degrees. And in fact, it's going to be less than 180 degrees because it's between 90 and 180. And to actually find its measure, because it has a reference angle of 30 degrees, we can just take that 30 degrees away from 180. And we see that the measure of that angle then is 150 degrees, which I'll leave it to you to confirm doing the conversion that gives us 5 pi over 6. And now the next question is, what will the cosine and sine values be? Well, again, remember that they correspond to the values for the reference angle. So the reference angle, was 30 degrees. So the cosine and sine of 150 degrees are going to correspond to those values for 30 degrees, which in this case turn out to be √3/2 and 1/2. So we know the coordinate here will be √3/2, 1/2. But because we're in the second quadrant, okay, we also have to think about the signs here. So the x values are falling along this axis here, which we actually know is the negative part of the x-axis. So that means that our x value, √3/2, needs to be negative. The y values have to do with this upper part of the vertical axis, which those are all positive, so we can leave the 1/2 as positive. So we see that the cosine and sine for 150 degrees, or 5 pi over 6 radians, is negative √3/2 and 1/2. Okay? Now you can go through and fill in all the other angles in the unit circle using a similar process. And I would highly suggest that you take the time to do that for yourself so you can see how the unit circle is built. All right, so I'm going to leave that there for now. Leave that for you to do. And once you've got it done, then there's actually some places where you can check your work. So I'm going to go to our WAMAP course. If you go down to the Chapter 5 folder, open that up, and then go into the Class Assignments and Handouts folder, you notice right here, the third link down, there's a link to the unit circle. So if you open that up, you can actually see the full unit circle with all the cosine and sine values and angle measures in degrees and radians filled in. So once you fill out a copy of the unit circle for yourself, I would highly suggest checking your answers with this. Also in this folder, you'll notice right below that there's a copy of the blank unit circles. So if you have access to a printer and would like to print one out for yourself, or maybe just work on it on your touch screen device, you can do that. Okay. All right, that is it for now. Thank you for watching.